In this video, we will talk about how to simplify cube roots. So let's say we would like to find the cube root of 32. How can we do that? Well, there are two methods that people usually use to find the cube root, and I'm going to show you how to use each method. So the first method is you can factor 32 using values that you know have perfect cube roots. So over here in this left-hand column, I've written some cubed values. So 1 cubed, or 1 times 1 times 1, is just equal to 1. 2 cubed, 2 times 2 times 2, that's 8. 3 cubed, 3 times 3 times 3, that's 27. So I've written all of the cubed values from 1 through 10. So the idea here with this method is, can we factor 32 using one of these values, one of these perfect cubed values? Well, 8 is a factor of 32, so we could rewrite this as the cube root of 8 times the cube root of what other number? 8 times what is equal to 32? Well, that'd be 4, so we'd say the cube root of 4. Now, here's the neat part about this method. The cubed root of 8, this right here, is just equal to 2, since 2 cubed is 8. So this whole expression right here simplifies to 2, and we're left with the cube root of 4, which does not have a perfect cube root, so we can just leave it like this. So that is our final answer. Now, the second method that you could use to simplify this cube root is to perform prime factorization. So that's where we factor 32 until we're only left with prime numbers. So for example, 2 times 16, 2 times 16 is equal to 32. So we'll notice that 2 is a prime number, so that means we're done with that one, but 16 can be factored a little further. So let's do that. We could say 2 times 8. Again, 2 is a prime, so we're done there, but we can factor 8 even further. Let's say 2 and 4, and then 4 can be factored into 2 and 2. So we're done with our prime factorization because we're only left with prime numbers. So using this method, we said we want to find the cube root of 32. So because this is a 3 right here, we're looking for groups of 3 of the same number. So for example, here are 3 2's. And just that we can't form any other groups of 3. So here we have 2 2's, but we're looking for groups of 3. So this is the only group of 3 that we can pull out. So what we can say is whatever this number is, we can just put that in front of the cube root. So we have 2 times the cube root of whatever values we're not able to form a group of 3, those have to stay under the cube root. So we're left with 2 times 2, which is 4. And notice this produces the exact same answer as the previous method. Okay, let's try one more example. Let's say we want to find the cube root of 54. I'll show you how to do that using both methods again. So remember this first method, we're trying to factor 54, and we want to try to use one of these perfect cubed values to do so. So if we're looking at this list, we'll notice that 27 is a factor of 54, because 27 times 2 is 54. So what we can write is this is equal to the cube root of 27 times the cube root of 2. Remember, because 27 and 2 multiplied together makes 54. So the cube root of 27 is just 3. So this can be simplified to 3. And the cube root of 2, it's not an integer, so we'll just leave it as the cube root of 2. So that's our final answer. Now, what if we wanted to use prime factorization instead? Well, that's where we break down 54 into factors until we're left with primes. So let's say we want to start with, let's say 6 and 9, since 6 times 9 is 54. 6 can be broken down into 2 times 3, and these are both primes, so we're done there. And then 9 can be broken down into 3 times 3, and those are both primes, so we're also done there. So remember, we're looking for groups of 3 numbers that are all the same value. So here is a group of 3, and we said when we have a group of 3 like this, just pull this number out front in front of the cube root. So we're left with 3, and since this 2 is all by itself, it has to stay under the cube root. So our final answer will be 3 times the cube root of 2, which is the exact same answer that we got using this method over here. So those are the two methods that you can use to simplify cube roots.